If y is equal to x times e to the x, find the third derivative and form a conjecture for the nth derivative. Prove your conjecture by mathematical induction. So we've got y is equal to x e to the x. This is a product, so we need to use the product rules. Type uv. The product rule says d dx of uv is u dv by dx plus v du by dx. So dy by dx will be u, which is x, times the differential of e to the x, which is e to the x, plus v, which is e to the x, times the differential of x, which is 1. And that gives me, if I take out e to the x, a common factor, we get x plus 1 e to the x. For the second derivative, we're going to have x times e to the x, which is going to be, give itself x times e to the x times e to the x times plus another e to the x, which if we differentiate, we just get e to the x, and therefore we can get x e to the x plus 2e to the x, which gives me x plus 2e to the x. And for the third derivative, we're going to get x e to the x plus e to the x for this, and then we're going to get when we get 2 lots of e to the x. If we differentiate 2 lots of e to the x, we get 2e to the x. So therefore we now have got x plus 3 e to the x. So we can see for the nth derivative, possibly it's going to be x plus n e to the x. So the nth derivative, my conjecture, dn dy dx to the n, will be x plus n to the e to the x. Now we can possibly now we're going to prove this using the principle of mathematical induction. Okay, so the proposition is that if y is equal to x e to the x, then the nth derivative is x plus n e to the x. So I'm going to prove the result for n is equal to 1. So dy by dx is equal to x e to the x plus e to the x times 1, which is x plus 1 e to the x. Therefore, it's true for the first time that we differentiate it. Right, we assume true for n is equal to k. So that means that the k derivative will be x plus k e to the x. And then in order to find the k plus 1 derivative, we need to differentiate this again. So prove true for n is equal to k plus 1. We need to differentiate the k derivative. So that's going to be d dx of the assumption x plus k e to the x. So that's going to be x e to the x plus k to the x. So differentiating that, we get this bit here, we get x e to the x e to the x. Differentiating this, we just get k e to the x. So here we got 1 plus k, so we got x plus 1, x plus k plus 1 e to the x, which gives me what I wanted. Got x and then k plus 1 from here. Therefore, the result is true for n is equal to k plus 1. And therefore, if the result is true for n is equal to 1, and if it's true for n is equal to k, it's also true for n is equal to k plus 1. Therefore, the result is true for all n belonging to positive integers by the principle of mathematical induction. I.e., if I differentiate it once, because it was differentiated for some general value and I got the next value, then it will be true for n is equal to 2, 3, 4, and then so on. Okay, so this has been a video to show you how to do proof by induction for a derivative. I hope you understand, and I thank you very much for watching.